Quick review here over chapter 4. I don't think we need a ton of review. It's all should be pretty fresh. So the types of questions you're going to see out of chapter 4. So section 1 was like those discrete versus continuous graphs, being able to read a chart or read a graph where, I say, I give you a graph that looks like this, age and height, and you have to pick which description depicts that person's path, right? So like this person at, their age and height, they started growing at a constant rate. They weren't growing in here, and then they had a quick growth spurt, and then they were done growing the rest of their life, whatever. It could be a question of I just give you a scenario and ask you what would be a better representation, discrete versus continuous. Simple multiple choice question. If I say a hose filling up a pool, would that be discrete or continuous? Hose filling up a pool. Continuous. If I said number of people entering a stadium, that why discrete? Can't have half a person, right? Things like that. So be able to answer those types of questions. Domain and range. So whether I give it to you as a set of points or a map or a graph. So in any of the three forms, I give you a set of points, 4, 2, -1, 3, whatever. I ask you domain and range, and is it a function or not? Domain is all the x's, range is all the y's. How do you tell if it's a function? What can't you have to make what causes a function to be bad? You can't have two x's the same with different y's. All right? Can't have the same x repeated that has a different y. What about in a map? What can't you have? Because you have domain and range, but what causes it not to be a function? Can you have two arrows going to the same number? Yes, but what can't you have? You can't have two arrows leaving the same point going to different numbers, right? So you can't have that. You can have this, but you can't have that. How do you tell it's not a function if it's graphically? Vertical line test. That would not be a function because it would fail the vertical line test. What if it looked like this? Yes, that would be a function, right? Because that would pass the vertical line test. Easy? Independent versus dependent variables. So your semester grade and your exam grade, which one's the dependent, which one's the independent? Which one depends on the other? Your semester exam grade, your exam grade tomorrow, or your final semester grade. Which one is the dependent variable? Which one depends on the other? Your final grade, your final semester grade, depends on your exam grade, right? So your exam grade is the independent. The dependent would be, right? how could you make your exam grade a dependent variable? What does that depend on? Not really. What does your exam grade depend on? Your knowledge, your studying, right? How much you prepare. If I gave you this, f of x is equal to 7x minus 3, and I said, find this. What do you do with a negative 3? Just plug it in. So 7 times negative 3 minus 3. Negative 21 minus 3 is negative 24. Easy enough? That's probably all you need out of that section. We've already talked about that stuff. Yeah, drawing graphs. So you guys, we've already talked about drawing graphs. Positive, negative correlation, scatter plots. How do you recognize a positive correlation? The data looks like it's going up. Negative would be coming down. No correlation would be all scattered. Another type of question I could easily give you is I could just give you a general statement or a general scenario and ask you, would you expect to see a positive, a negative, or no correlation? If I said if I did a chart of how many hours you spent studying compared to your final exam grades, would you expect there to be a positive, a negative, or no correlation? The more you study, what generally would that cause your exam scores to do? Also go up, right? So if they both go up together and both go down together, that's going to be a what type of correlation? Positive correlation. A negative correlation would be how many let's see, how about how much snow we get versus cars on the road. The more snow we get, generally what happens? Fewer cars on the road because people look outside and go, I ain't going out there, right? So that would be a negative correlation. The more snow we get. Now, how could you have more snow we get and make it a positive correlation? The more snow we get, what also goes up? What? Higher chance of a snow day. Yep. The more snow we get, the higher chance of the snow day. The more snow we get, the more car accidents there are, right? Things like that. Those are positive correlations because they go up together and go down together. If they go opposite directions, that's a negative correlation. How about the more snow we get today compared to your exam grades tomorrow? Positive, negative, or no correlation would you expect? Should be no correlation, to be honest. Like that to me would be, shouldn't have much of an effect. All right, make sense? And then, the last ones are the sequences. What's the arithmetic sequence equation? A sub n equals a sub 1 plus d n minus 1. What is the a sub 1 stand for? That's the first term. What's the d value? That's called common difference. Basically, what is it going up by, right? And then the n is just the number of terms, right? So, here's a simple arithmetic sequence question I could give you. I'll give you this. I'll say 7, 10, 13, 16, and so on. Find the 32nd term. How do I do this? I'm looking for a sub 32. What goes first? What's my a sub 1? So 7. Plus, what's the d value? 3, because we're going up by 3 each time, right? And then in this case, what's n minus 1? 31. So I would just do 3 times 31, which is going to be 93. 93 plus 7 is 100. The 32nd term is 100. Easy enough? And with these, I could give you this pattern and just ask you for the d value. What is the common difference? And you just say 3. I could ask you for the next few terms. I could ask you for any random term. Easy enough? Gosh, that's really it. That's the whole chapter right there. It was a kind of a shorter chapter. Anything from the review that kind of stumped you? All right.